So the first example, it's y is equal to 8 minus then 3x plus 2. So before we even start, we can just try to refresh our memory on what we did earlier on about getting the domain and the range. So according to what we said, the domain for your modulus function, we say the general case is always going to be all real numbers, or rather from negative infinity to positive infinity, all numbers allowed. You can put anything here, it's still going to be defined. Then for the range, we said for the range, it depends on the number which is outside here. So the number which is given here is 8. So we're going to say y is supposed to be, this is facing down, so this has to be y is less than or equal to 8. Or rather, I can show it to you here to say we are having f of x is equal to this. We can first of all worry about this part here, this part. First of all, worry about this. That's what you're interested in. That's the first thing you do. So let y be equal to 3x plus 2 in modulus expressions. I gave you a quicker way of sketching this. You can just ignore the modulus expressions, make your table of values, x and y, put a 0 there, put a 0. When you put a 0 there, you get a 2. When you put a 0 on the other side, where there's y, when you put a on this guy here, 3x plus 2, when you put a 0 here, this is just going to give you x is equal to negative 2 over 3, right? Negative 2 over 3. So if we try to sketch this using these 2 points, we're simply going to get something that turns over at this guy. So this is 0,2 somewhere there, and also negative 2 over 3. So this is initially supposed to be a line that comes like this, right? This is how the line was supposed to be. But because of the modulus, we said we always reflect the part which is down upward. So if there's any piece of the line which is down, reflect it up 90 degrees. So this is going to go like that. So that's what we're having. Then we have to move this thing up by 8 steps. But before we do that, there's a negative in front. So the negative here, this negative that you're having here outside, the negative is implying that there's the graph is going to face down. So it has been, this is 3x plus 2. But when you reflect it down, it's simply going to look like this. It now crosses at negative 2 there. This is negative of 3x plus 2. That's what it means whenever there's a negative in front. So I can erase the black one because we've already used it. Then after sketching this one here, we have to move this 8 steps up because we've done this. Now we have to apply the 8. So this moves upward by 8 steps. The points that were at 0 will come at 8. So we have 8 somewhere there. This point will come there at 8. The point which is at negative 2 plus 8, that's going to give us something like a 6, right? So meaning your graph actually comes like this. This is the final graph. Looks like that. Except we have to show the part where we're touching the x-axis.
You can just speak.
On which part, Christopher?
8, I'm not clear.
On the 8?
When we are shifting our graph.
Okay, you're okay with it facing down like this, like the way it's facing down like this because of the negative, right?
Yes.
So now we're just saying we need to move it 8 steps up. So anything that is on this graph has to move up by 8 steps. So we are starting with negative 2. I started with negative 2. This point here is going to come at 6. 8 steps up. So this is, there are 2 steps there coming at negative 1. Then this is 1, 2, 3, 4, 5, 6. Together giving us a total steps of 8. The distance has to be 8, right? So negative 2 plus 8 is 6. So those are the 8 steps. We land on 6 in the positive y-axis. So we're here. Then the point which was here, this is at 0, right? This is at 0. Y is 0. So 0 plus 8 simply gives us 8. So 0 comes at 8. So now we can now sketch this. So it will give you something that just looks like that. And from here, we're going to be interested in getting the point which is here where we're touching the x-axis, and also this point which is there. So already know this point here is the same as negative 2 over 3, comma 8. That's the point there. Already notice the domain is y is less than or equal to what? 8, right? I mean the range, sorry. The domain we said it's all real numbers. The range was our problem. We said it's going to be that. That's our range. Then from here, how do we get the point where we're touching the x-axis, these 2 points? We equate the whole thing to 0. We're looking for the x-intercept, so we equate everything to 0. This is just going to give us a 0 is equal to 8 minus your 3x plus 2. Then take the 8 on the other side, it will be negative 8, negative 3x, then plus a 2. Then here you can square both sides. First of all, cancel the negative. The negatives are going to cancel. Then this is just going to be like this. We square both sides. You square this side and you also square this side. This will give us a 64 is equal to, this will be a 3x. Okay, so we're multiplying this by itself twice. When you multiply 3x plus 2 by itself, you get 9x. Then this is going to give us a 12x, then plus a 4. You take the 4 this side, yes, of the modulus. What does the same thing as modulus is simply the squaring. Modulus means making something positive, right? What modulus does, also the squaring does. So if I give you, how can I say this? If I give you modulus of x is equal to what? Is equal to 4, for instance, right? So here we're just saying you square both sides. Remove the x, square this side, and also square the 4. So that it allows us to accommodate numbers, because when you are back here, you are saying x could have been either what? Plus or minus 4, right? If you put modulus of negative 4, the answer is your what? 4. If you put modulus of 4, the answer is your what? 4. So squaring ensures that we cater everything that has to do with the modulus. Yeah, so we replace the modulus with squaring both sides. What we do to the left, we also do to the right. Or alternatively, if you don't want to do that, you can just give us both cases. Remember we said these modulus expressions can be redefined to give us 2 pieces, right? This can either be the positive piece, this guy here, or the negative piece. So you can just solve this is equal to 8, you get your answer. This is equal to 8, you get your answer. It's the same thing as what we are doing here. So we are squaring both sides to replace the modulus symbols, because how else can you remove the bars? You cannot just ignore the bars. Yeah, so to replace the bars, but without changing the meaning, that's the reason why we are squaring both sides. Yeah, so this is going to be 9 that plus 12x will bring this. This is going to be 60 because 4 minus 64, right? Then from here, 3 can divide everything. That's 3x. This is going to be a 4x. This is a 20. This is equal to 0. So the product that I'm getting is a negative 60. Then the sum is simply a 4. So what factors can we use? Can these guys work? Yes, this they can. So this will be 3x squared minus 6x, then plus 10, x then minus 20 is equal to 0. This will be 3x, x minus 2, then plus a 10, then x minus 2. So this will give us 3x plus 10 and x minus 2 is equal to 0. So we are simply going to have x is equal to negative 10 over 3 and x is equal to 2. So we have two answers. Beauty, was this okay? Was the explanation okay? Did you get it? How or why we are squaring both sides?
Yes.
Yeah, so however you manipulate it, but it has to make the meaning has to be preserved. It doesn't have to change the entire meaning of the whole expression. So this is basically what we're supposed to have. Yeah.
Oh, sir.
Yes.
Yeah, concerning removing the modulus, I came across like for you to move it, you're supposed to say square root, then open bracket. The number that's supposed to put inside close bracket, then square again. I don't know if that is correct.
Okay, so Swilangia sent some questions. Okay, so let me get what you're saying. Joseph Siame, you're saying you found something that says what?
Yes, I was saying for you to remove the modulus, you're supposed to involve the square root and the square. I don't know, that was what I was told.
Okay, so let me try to get the picture of what you're saying. So if I give us something like, is it like a function or an equation form? Let's say I give you this. Or you mean, can I give you something that looks like this? Let's say I give you this. How can we solve it? How can we solve this guy here? You're saying I put a what?
Square
root on both sides?
Open bracket. No, not on both sides.
Okay, so I put the square root and put the x plus 2 inside?
Yes, put it in brackets.
This guy is like this?
Square it again.
I square it. I put a 2.
Yes, a 2.
A 2 outside. So if I was to do that, you mean like this or like inside?
Inside.
Inside, okay. So if I put a 2 there, then this is equal to even this other side?
No, that's all.
That's all.
I put a 3 that side.
I put the 3 here.
Yes, I mean, you said manipulation, but I feel like maybe you may end up with the same thing.
This is actually going to, how can I say this? Oh no, yeah, it's actually, if you say that, that's you okay. Okay, so if you say that, you still are going to get the same thing because you're saying the square root of x plus 2 in this. So now there's a 3 this side. How do we get rid of this square root? How do you solve this? X is equal to 3. You square both sides, right? So even here we're going to square both sides. When you do that,
yes,
this cancels with the 2, leaving x plus 2 squared. The 3 is 2 squared. That's going to be a 9. You see that it's just the same, right?
Yes.
Yeah, so it just becomes the same here. So a simpler way to say it is, if you're given something like this, just square, remove the modulus, then square both sides. What you do to the left, also do to the right. Then solve this. It turns out to be a quadratic, then to just be straightforward.
Yeah, this one is even better.
Yeah, so that's basically what you have. Either way, the outcomes is still going to be the same. Then the next, the other questions that. Okay, so Swilanja sent a question, 3 questions. The first one is almost similar to what we did at first, so modulus. It's on modulus. So this is y. There's a 3, then minus this minus that. So firstly, let's start with the domain, guys. Let me see if you understood what we said about the domain. What's the domain of this function going to be? What have we said about modulus, guys? What's the domain? It's a general thing. It never changes. What's the domain of a modulus?
Real numbers.
All real numbers, yes. All the real numbers. You don't even have to think. It's always going to be like this. All real numbers. Then the range depends on the number that you're having this side. So you're seeing there's a negative here, meaning this thing is going to be flipped down because of the negative. And then there's a 3. 3 is the boundary. So there's a 3 somewhere there. So all numbers less than 3. So y is less than or equal to what? 3. That's the range. So we start by sketching from the left going to the right. Yeah, so we start by applying the rules. By looking at this first, we go like this. So what's the sketch of x minus 1? I said you just ignore the modulus first, or rather you can, to follow the rules to score the proper marks that you need to score, you have to redefine it. Negative this. There are going to be 2 pieces. X minus 1 is greater than or equal to 0, or x minus 1 is less than 0. Redefine the 2 pieces. There's this piece and there's this piece. X is greater than or equal to 1 and x is less than a 1. So you always, let me slow down a bit. You write this thing here without a negative. Or let me say you write it with a positive in front and you write it with a negative in front. Then again, you write the same thing, greater than 0, greater than or equal to 0, and the same thing, less than 0. We're saying if it's already positive, if this thing is greater than 0, leave it to be the way it is, not that it's positive here. But if this thing is less than 0, meaning negate it. That's what it means to put something in a modulus. If you put negative 4 in a modulus, for you to get it outside the modulus, you negate it, you multiply it with a negative, it comes out as what? Positive 4. If something is already positive, you leave it to be the way it is, because it's already what? It's already positive. That's what this whole redefining means, or rather implies. That's what you're going to have. Then you solve this piece. This is what you get. You're supposed to sketch each piece here. There's a first piece, which is only going to be seen after 1. So like I did previously, you're going to solve this. It gives you a 1. So at 1, and here is supposed to be, so I said you make a table, the easiest. This is y is equal to x minus 1. Put a 0 here, put a 0, x and y. So that for the fact that x is equal to 0 gives us negative 1, and when y is 0 gives us what? Gives us a 1. This is going to be a negative 1 and 1 comma 0. So the graph is supposed to come like this initially. This is how the graph was supposed to look like. But remember, we don't accommodate negatives, right? So any piece which is in the negative has to be reflected what? Up. So this will come like that, passing at 1. So we're going to ignore this down part here. Then we're now going to reverse it because there's a negative in front. Remember how the question is? There's a negative here. So this is a graph of x minus 1 without a negative. When we apply the negative, this thing goes down. It's simply going to go there, and it faces down like that. That's a negative modulus of x minus 1. Then we move this thing up by 3 steps because there's a 3 here, right? Because of this 3, we move it up by the 3 steps. So negative 1 will come to what point, guys? Negative 1 will become what? Negative 1 plus 3. Negative 1 plus 3.
Negative 2.
Positive 2, right? So the point that was on 0 comes at 3. Then this point just comes there at 2, passes like that. The other one passes like that. So our last task is to just find out where we are touching the x-axis at these 2 particular points. Yeah, so now we're going to just solve the whole thing, equate everything to 0. We're saying 3 minus x minus 1 should be equal to 0. Negative x minus 1 should be equal to negative 3. The negatives can cancel. This just gives us a 3. We can just square both sides now. This is just going to give us a 9. This is x. I can just solve it to be the way this is plus or minus 9. That's plus or minus 3, right? The square root of this, if I square root here, this is going to give me x is equal to 1 plus or minus 3. So the values of x that I'm getting is 1 minus 3, that's going to be negative 2, or that's 1 plus 3, that's simply a 4. Yeah, so meaning we are touching the x-axis at negative 2 and at 4. That's basically what you get. Is this okay, guys? Madam Swilanji, is this okay?
Yes.
So the same would apply for the second thing. For the second question, though there's a negative in front, we'll simply do the same, except this time around the expression now goes down by those number of steps. So it's the same procedure, guys. So this is just going to be, this is y is equal to negative 2, then plus, this is x plus 4. So already, hope you're okay with this guy here by now. Just solve what's inside. This is x is equal to negative 4. So go where negative 4 is on the x-axis. X is equal to negative 4 is here. Make a v. So make a v. It looks like that. Where do we touch this point here? Go back to your y is equal to x plus 4. When x, put a 0. Put a 0 there. What do you get? Y is equal to 4. So we are touching this guy at 4. This is the first part. If if I may draw it with dotted lines. Yeah, so this is the first part. And lucky for us, there's no negative in front. It's just okay, it's positive. So we've done the hard part, which is this part here. It's done. This part is done. The next thing now, we have to move this thing 2 steps down because it's a -2, right? So 4 plus -2, that's going to come at 2. Then everything comes at -2. What was on 0 comes at -2. So the graph is now going to look like this, something that looks like this, and passes here at 2. We need to pass at 2 on the y-axis. So we're still here. So we need to find these 2 points, point A and point B, where we're touching the x-axis, by equating the whole thing to 0. And when you do so, this is just going to be -2 plus x plus 4. Then equate this to 0, take the 4 on the other side. This will just give you a 2. Then this will give us x plus 4 squared is equal to 2 squared, that's a 4, right? You can just do this. Square this side, that's x plus 4 is equal to plus or minus 2. Then x is equal to -4 plus or minus 2. So this is going to give us a -6, or it's going to give us a -2. So we're touching it at -2 or -6. So this is basically how your graph is supposed to look like. Any questions, guys, up to this point? Given, this is interesting. They've given us y is equal to, there's a 3 plus, then there's x squared and minus 4x squared. So quickly, guys, let me see if everyone is up to date. Oh, this is just what? This is just x. So if I was to give you this, y is equal to x squared minus 4x. What's a completed square form of this guy here? If you complete the square of this quadratic there, what do you get? Can you give me the a, the x plus the b, or minus, I mean? So I'll put minus here. Can you give me the a? What's the a going to be? When you complete the square of this quadratic, I want it to be in this form. So what's the a going to be?
I don't think we're going to have an a there.
What's a here, beauty? What's the coefficient of x squared? What's in front of x squared? 1. Yes, we do have an a. An a is 1. Then what's b going to be? 2. Then what's p going to be? P is going to be what? What's P, guys, going to be? -4, right? Remember the formula? We said the formula is what? A, x plus b. How you complete the square of anything. This is going to be your 4ac minus b squared over your 4a. So when you're done solving this, it should give you a -4. So that here you're able to know the turning point. I just did this for you to get the turning point. The turning point is when you solve what's inside there, that's a 2. Then what is outside, bring it the way it is, which is that. So now we're able to see that the turning point is simply your 2, -4. That's what you have. Yeah, so now we are going to have something that looks like this. There's a 2, -4. There's a 2 and -4 somewhere here. So your thing is turning from here. And when you solve this without the y, if I put a 0 here, when you solve this to be equal to 0, what are the 2 answers of x that you're going to get?
You get x is equal to 0 and x is equal to 4.
You get x is equal to 0. Just factorize x here, guys. X minus 4 is equal to that. Then you get these two answers. So you are saying there's a 0, then there's what? There's a 4. So this is supposed to pass there. And it's supposed to pass there. It's supposed to look like this. This is your quadratic function without factoring in the fact that it has a modulus bounding it. So this is what you get first. The turning point, you already know it. This is what you have there. Then remember the question. The question has a modulus expression, and we are having what? There's no negative outside. It's just okay. So the question was, or the question is y3 plus this x squared then minus 4x. So how do we affect the modulus? This here is x squared minus 4x. How do we apply the modulus on this guy here? Modulus on the quadratic. How do we show that the modulus has been applied?
So the curve that is done will move upward because the modulus is always positive.
So modulus makes everything positive. So this portion which was down, we move it up. So it's going to be up there, meaning the turning point has now changed from being at 2, negative 4. It's now at 2, 4. The turning point has now gone to 2, 4. So the guy in red is what you're going to get. So let me just try to make this a little bit straightforward. So the guy in red was supposedly our initial graph. This guy here is supposed to turn here, then go like this. Then now we are saying we are shifting it. It's going to be like that. Yeah, so the dotted lines here now can be ignored at the bottom. And so these guys can be ignored. We're just interested in the ones that have remained now, these dotted lines that you're able to see. This is how the function looks like. After applying the modulus. Then we have to move this thing upward by 3 steps. That's what you have because there's a 3 in front. So everything that was on 0 comes at 3. So it's like we're just changing our line of axis from 0 to 3. So this is just going to be here at 3. Remember, this is at 4, right? This is the turning point you've made to move up. This is 2, 4. So 3 is somewhere here. Let me use a different color. So 3 is somewhere here. Everything moves at 3. This is 3 because we're adding 3. 0 plus 3 is that. Every point comes there. This point also comes there. Then the point that was on 4 moves up as well by 3, right? So 4 plus 3 will simply be 7. So now we are having 7 there. So we're now just going to write this as our new line of axis so that you're able to see that the graph just comes like this, then goes there at 7, then comes back at this, then goes back like that. So the one in purple is our final thing, which has been moved up by 3 steps. So this is what you get. Everything has gone up. And it no longer touches the x-axis. So this is basically what you have. The points here are still the same. This is U0, this is U2. So this turning point now is what? Is 2, from being 2, 4, we've added the 3 there, is now 2, 7. So this is what you get. This is how the sketch was supposed to be. Hope this is okay. Any questions, guys, here? Swilanji, is this okay or it's confusing?
I think it's just okay.
It's just okay.
It's okay, sir.
It's okay. Okay, so let's say we have the last one that you sent. Let's look at, okay, let's try the last one that you sent is f of x should be, if I'm seeing it clearly, that's x squared minus 4. So you're seeing that there is no b here, right? It's just like I give you x squared. X squared is simply something that looks like this, right? This is the normal form of this. Then they are saying we move it down by 4 steps. So I mean this thing came down by 4 steps, meaning it simply passes there now. And when you solve this, equate it to 0, x squared is equal to 4, square root both sides. The values of x are simply going to be a negative and a positive 2. These are the two numbers or places where we're touching the x-axis. Now, there's a modulus, right? There's a modulus. So meaning the portion which is down here has to be pushed on top. So this part will be pushed on top. So our answer will just be the guy I'll write here in purple. So just this going up like that. Not the guy in black. So this is how your final expression is supposed to look like. Just accommodating positive things. And the domain here is going to be all real numbers. The range is y being greater than or equal to 0. All numbers greater than 0 are the ones that are accommodated. Yeah, this is basically what you have. Yeah, so hope this is okay. And for you to score all your marks, even if they are not asking for the domain or the range, whenever you are sketching, it's just okay and very much advisable for you to write the domain and the range. You just show the marker that you actually understand the concepts and you know what you're doing. Because the domains and the ranges are going to validate whatsoever that you're going to sketch. Yeah. The rest of the rough work you'll be doing has to be dotted. The final answer is the one that has to be bold. So like here, we already said modulus, domain is all real numbers. The range, according to this, y is greater than or equal to 0 because it's above the x-axis. So this is what you'd have.
We find the domain.
We find the domain, and the domain is going to be found by solving the denominator because this is a rational function. So before you even solve a question, this is how you're going to be finding functions to be very easy. First of all, after mastering all the types of functions, before you attempt a question, you ask yourself, is this a mixture of functions or just one type of a function? This is case 1 under rational functions, where the denominator is having a bigger power as compared to the numerator. This is bottom heavy. So we're going to solve the down part to get the domain first of all. So the domain, when you solve this quadratic, you get two answers, which is what? Is it your 4 and your 2? So we're saying all numbers are allowed, but x should not be equal to 2 and it should also not be equal to 4. Yeah, so someone to just confirm whether you're getting 4 and 2. So this is the domain. Then the range, what did we say the range of this case is? All numbers, but not what? Not 0. 0 is not allowed. This is fixed. It's always going to be like this, provided you're looking at this particular case. Then these numbers that have not been allowed by the x-axis are the ones that we call the vertical asymptotes. X is equal to 4 and x is equal to 2. The number which is not allowed by the range is what we call the horizontal asymptote. All the time, that's the y is equal to 0. So hope you're okay with this.
Isn't it supposed to be -4 and -2?
If we were to solve it, let's solve it. If you are sure that is, because I just did this thing in my head, let's see if that's what we'll get. So if we put our factors are what? The factors are going to be -4 and -2x. Then you have +8. This is equal to 0. The product was 8. The sum was 6. The factors are -4 and -2. Then when you solve them here, you get x minus 4. Then minus...
The sum is -6.
The sum is -6, right? Yes, -6. Then we have -4 is equal to that. Then this is x minus 2 and x minus 4. Then we solve both of them. This is going to give us a 2. Then this gives us a 4. So whenever you get your factors, the answers are going to be the same factors but with different signs. So the factors are -4 and -2. So the answers will be 4 and 2. That's how I figured to say the answers will be this. Hope that's okay.
Oh, okay.
Yes. So that's what you get. Yeah, so if everyone is okay with the vertical asymptotes and the horizontal asymptote, the next thing to get here is the x and y intercept. Yeah, so the x-intercept is when y is 0, which does not exist in this case because the x-axis is the same as y is equal to 0. So we cannot have an intercept. Other special cases can, but here we're saying the x-intercept won't exist because we are not supposed to cross the x-axis. Even when you put 0 this side, put 0 is equal to -4 over everything that you have down, it won't work because if you cross multiply, this thing becomes -4 is equal to 0, which is false. And we're saying the x-intercept does not exist. We put DNE, then the y-intercept, we just put wherever there's x, we put a 0, so y is equal to what? Put a 0, that's going to be -½ because this is going to be 0, 0, -4 over 8, 4 into 4, and then 4 into 8. So this is the information that we need for us to sketch.
Frank,
Yes.
can you explain why the x-intercept doesn't exist? I didn't see that part.
Okay. The x-intercept is gotten by us equating everything to 0, right? We need to put 0 where there's y, or rather where there's f of x. So if you put a 0 here and try to solve it, this is -4. Then down here it's x squared minus 6x, then plus 8. When you cross multiply, what do you get? You are going to get 0 is equal to -4. Is this mathematically true? No, it's not. So it implies that the x-intercept does not exist. And the other reason why it does not exist is because the x-axis is equivalent to you saying y is equal to 0. And this is the line that we are not supposed to cross. So that's the reason why we are not having an intercept on the x-axis, because it's the horizontal asymptote. It's the line that we're not supposed to cross with respect to the y-axis, because you know how y values are read if you're looking at a graph, right? If I give you to say you have what, 4, we read these like this. They're going to be going in the horizontal, right? So y is equal to 0 passes exactly at the x-axis. The x-axis is your y is equal to 0. We're not supposed to cross this, so how can we touch it and also not cross it at the same time? So that's the reason why there's no x-intercept. Is this okay?
Yes.
So now, okay, just a minute. So now the next thing is for us to be able to sketch. First of all, we start by placing the asymptotes so that we don't make any mistake. So the asymptotes, the numbers we are not allowed to cross or touch. On the x-axis, there's what? There's a 4 and a 2, right? Is it? Yeah, there's a 2 and then there's a 4. These are called vertical asymptote. I hope wishing if Sif was here. So they are called vertical because the x values are going to be read like this, perpendicular, right? Like straight like this. So these are the vertical lines we should never touch. So these have been indicated. Then the other guy is the horizontal asymptote, which is y is equal to 0 directly on the x-axis. Then the y-intercept, where we need to touch the y-intercept is at -½ this part here. We need to touch -1/2. So meaning, if we have to touch -½ meaning we have to come from this direction. So the first piece will be from here, coming like that, then it's going to be like that. That's what you have. That's the first piece with respect to the y-intercept. Then we test. We have a 3 here in between, right? We need to test. You can't just guess whether the piece here will be here or will be down, because each region has to be represented. Between these regions, A and B, the correct region is B, right? Because we have to touch -2, -½ So that's okay. We have settled this. How about region between C and D? Which region should we have a piece? And also between E and F, which region should we have what? A piece. Yeah, so one piece will represent both regions, like it will cater for both. So that's what you should know. So like here, we're going to test by putting 3 in the function. When you put 3 in the whole function, this is equal to, there's a -4 on top, there's x squared minus 6x then plus 8. When you put 3 there, that's going to give us a 9. This is a 9 minus 18, then plus 8. This is going to give us -4 over. This is a -9 plus this, that's a -1. The answer here is 4. So the outcome is 4, which is positive, meaning the piece has to be on the positive part. So the piece here has to be like that. That's the testing that we've done. Then on the last part, we also have to check, but it's just logical that the piece has to be down after 4. So let's say we try 10. If I were to put 10, we see where the piece is supposed to be. There's a -4. Then down there, I put 10 squared, minus 60, then plus 8. Here it's going to be -4. This is 100. 100 minus 60, that's a 40, 48. So you're having what, 48. So it has to be in the negative. The y value when x is equal to 10 is in the negative. So the piece here has to be down like that. So these are the pieces of our sketch. We can erase the guys we're using to test. And this right here is going to be your sketch. So we end here, guys, for today. I'll record the class for logs. My phone is now on 2, so 2%. So let me try to charge my devices before power cut. Yeah, and I'll record the ones, the last part of logs that we have to do, and then send the recording